I am over the moon to be answering today's question. In fact, it's sending me positively loony. Sorry, I shouldn't wax on, should I? Your concentration's probably waning. Enough. No more terrible puns. That was a rocky start. No, awful. This film is about our nearest celestial neighbour, none other than Luna, our very own natural satellite, the Moon. It's the Earth's constant companion, orbiting our planet once every 27.32 days, its phases marking the passage of the months. But is the Moon any more than just a very rough calendar? Do we really need it? And would we miss it if one day it just wasn't there? Well, there's half a chance that we'd notice it was gone after a few nights, because thanks to the reflected light from the sun, a full moon can give enough light to see by at night. So without it, we'd be left with much darker skies than we're used to, which is bad news for getting around without a torch, but great news for stargazing. Without that bright disk of the moon oversaturating our eyeballs, we would have spectacular views of the Milky Way right through the month. However, this moonless life wouldn't spell a life of leisure for the many species of animals that rely on the phases of the moon as a pacemaker for their biological clocks, like acropora corals, who time their simultaneous release of sperm and eggs to a precise 1 or 2 days a year, when a full moon appears in the sky just after sunset. Or the streamlined spinefoot fish, which all choose to spawn during a waning quarter moon. Losing the moon would play havoc with these reproductive cycles and the species that rely on them, potentially leading to their extinction as they fall out of sync. And it's not just the light of the moon that animals rely on, but also the effects of its gravity as it progresses on its cosmic journey. Despite being only 2% of the volume of Earth and 400,000 kilometers away, that 22 billion cubic kilometers of cratered moon rock still has enough of a pull on Earth and its oceans to create our tides. Now, I'm sure this is one of the very few things that you remember from geography classes at school, up there with Oxbow Lakes, right? But let's recap. Tides form as huge masses of water are pulled towards the moon, creating a bulge on the side facing it. On the other side of the Earth, the moon's gravity isn't so strong, so the water there gets left behind, creating another bulge. Every day, most coastal areas witness 2 high tides and 2 low tides as the Earth rotates, allowing these bulges to circumnavigate the globe. No more moon would mean much smaller tidal bulges, since the distant sun would be the only body pulling on the seas. Therefore, the water would settle to create new, barely varying coastlines. Now, while most of us might feel a bit nostalgic for the loss of the tides, it's a bigger deal for all of the animals, the plants, and the human cultures that depend on them. Intertidal zones are the bands of land along every coastline that are submerged and then exposed by the tides on a daily basis. And they are an important habitat for organisms that like both the wet and the dry, like barnacles and mussels and crabs and sea anemones and seaweeds and many starfish. But the moon may be even more important than that. There's evidence to suggest that not just intertidal creatures, but all of life on Earth might owe its existence to our friendly rock in the sky. 4.5 billion years ago, when the Earth was newly formed, scientists think that it span on its axis at an alarming rate. Days would have lasted 6 hours, and the resulting Coriolis forces would have left the surface battered with intense winds and storms. But this all changed when another planet smashed into our early Earth, breaking off a bunch of bits that together formed the Luna that we know and love. With our orbiting moon in tow, the Earth experiences something known as tidal friction, where some of the Earth's rotational energy is lost as the tidal bulges move around the planet. It's a small effect, but over billions of years, it's been enough to slow the Earth's rotation so much that it now takes 4 times as long to spin all the way round. That means day and night cycles are a comfortable length, and weather systems are no longer terrifyingly strong. Longer days have made our world a much more hospitable place, and that's thanks to the moon. Incidentally, this tidal friction thing is still going on, and the length of our day continues to increase at a rate of 2.3 milliseconds a century. But in 1 million years from now, days will be an hour longer, which means an extra hour in bed. Nice one, Moon. But it doesn't end there. The orbit of the Moon is also critical for maintaining habitable conditions worldwide. At the moment, our planet's axis of rotation is tilted at a comfortable 23.5 degrees, meaning we have pleasantly moderate seasons. But a planet's tilt has a tendency to change, as rotating planets are affected by other massive objects in the solar system. If the axis becomes too horizontal, the Earth will literally be spinning on its side, and a northern hemisphere winter would see all of Europe, Asia and North America plunged into a cold darkness for many months at a time. Meanwhile, the South Pole would see soaring temperatures as the sun remains high in the sky for weeks. Such massive temperature fluctuations are certainly not conducive to life, so we can thank our lucky stars that we've got our Moon, whose orbital path seems to steady the planet's axial tilt, stopping it from ever straying too far and keeping conditions within comfortable limits. So, do we really need the Moon? Well, none of the other nearby planets have one like ours, but then they don't have life either. Just saying. Are you loony for the Moon? If you enjoyed this Earth Lab video, give us a like, let us know your thoughts as well in the comments below, and don't forget to subscribe to BBC Earth Lab for new science videos. I would be over them. No, I've used it. I've run out of moon puns!